Okay, so the recording is live, and let's continue. Today there will be two of us. Matt Fryer, our technology evangelist, will cover most of the cases related to data quality issues. And also, I will demonstrate a few examples as well. So there will be two of us. And speaking about us, or how about our experience, both Matt and I, we have many years of working in data transformation, dealing with different kinds of data automation, and we personally experienced what bad data can cause and what kind of problems it can cause. So, well, the things we will be talking today will be very much from personal experience. Let's continue, and a few words about why data quality is important. So we could talk about some theoretical aspects of it, that, well, data quality is important, and if you don't have good data quality, then your dashboards can become spoiled, and reports may contain wrong information. And if you use or if you build some kind of machine-to-machine automation, then your data can be distorted, or it can be damaged in some other system, like operational systems, or some business process automation systems. But today I wanted to make it more specific, more practical, and I prepared a case study using open sources, using internet, about the Northwell Health hospital system, which operates in New York and adjacent areas. And several years ago, they had a significant problem with duplicate records. This problem has been largely resolved since then, but back then, several years ago, that problem caused real problems, and led to financial losses as well. So what was the cause of this problem? Back then, Northwell Health had it was a system of 23 hospitals and multiple healthcare systems that contain different parts of patient records. The problem was that well, those information about patients, it was distributed across multiple systems. There was no one system with one set of records. Different parts of it lived in different systems, so they needed to join together in order to obtain a full picture, to get a full patient record. They needed to merge it together from multiple systems. And if you watched our previous webinars on merging data, then you know that when you merge data, it's when you can get duplicate records in your merge results, if the merge is not configured correctly. Also, a big source of errors and duplicates was caused by manual data entry, where people entered, created new patients without realizing that, well, this patient already exists in the system, so there is no need to create it again. You simply need to update existing records. But it was hard. Sometimes it was hard to find the patient because the information was spread across multiple systems. So sometimes the staff resolved to just create a new patient record, and that was a problem as well. And another cause of this duplication problem was that sometimes when people edited records, or they needed to create a new or update a patient record. They didn't delete the older versions. So sometimes in systems you can find a new patient, but also an old patient record. So all that caused a significant duplication of records up to the point where they had about 700 duplicate records created daily. And since they didn't deal with this problem in a systematic way, they collected a huge backlog of more than 200,000 potential duplicates. And this is, of course, caused big problems. So what problems? Well, first of all, they had a very high percentage of claim denials. So they created claims, but they were denied because those claims contained wrong patients. So they couldn't identify patients reliably. That led to wrong claims, and a high percentage of those claims were denied. So they were losing money on that. Second, because they couldn't find patient records, sometimes they had to prescribe certain tests twice or maybe 3 times, simply because they didn't have records about previous test results. So redundant medical care and redundant tests cost on average almost $2,000 per patient, and they had thousands of patients. The total money loss was estimated as 1.5 million per hospital, and they had more than 20 hospitals in their system, 23 back then. So one can do the math. It meant that they lost about $30 million annually on average. And because they had huge backlog with tens and hundreds of thousands of potential duplicates, they had to hire external contractors who would do data cleansing manually. And of course, that wasn't cheap. That was all contractor work. That's expensive, and they lost money on that as well. And of course, not being able to provide high quality of service and constantly running into all kinds of issues related by record duplication led to reputational losses, and that wasn't good as well. So the organization implemented certain measures to fix data quality, to establish procedures, and overall managing data quality, it's always an organizational issue where and it's always a process. So it's not just a one-time solution, but typically it's a whole process. A year ago, we had another more detailed webinar on data quality, where we describe this whole data quality process, where we start with identifying and investigating data quality problems, then understanding the roots of it, and then building systems that would detect them automatically, and finally a step where you fix those issues, or you either automatically or you assign it to people who would resolve it. Isomorph covers all of it end to end. But today we will talk about more practical cases when you run into data quality problems yourself, how to detect it, what tools you can use in Isomorph to identify data quality problems, and how you can fix it. And this will be the rest of our webinar. So at this point, I'll pass the mic to Matt, who will continue with the practical examples.
Thank you. I will share my screen and we can start things off. Okay, great. So yeah, as Dimitri said, previously we did a webinar on some other sort of ways we can detect data quality problems at volume in kind of live production systems and scenarios. But often one of the things we need to do first is we get a new set of data and we can't really work out what's in that data, you know, or how we need to create a workflow to detect those problems necessarily or fix them until we've explored the data and seen what type of data quality problems might exist in it so that we know what we might need to do. So we're going to go through those 7 most common examples, and the first Dimitri's already talked about quite heavily in that use case or that case study, shall I say, for us. But these are duplicate values. And they can be 2 sort of main categories of duplicate values. Some can be entirely duplicated rows in the data, where every field in that row is exactly the same. Or we can also have duplicates where only some of those rows are duplicated. And this is often important when we've got fields such as ID fields or key fields, where these can cause a problem. So in our table, we can see here, we have 2 number 2 product IDs, one for listed as keyboards and one listed as monitors. And so that could be a problem for us, but it's not the entire record that's being duplicated. It's just that important product ID column. Now, these duplicates can cause all sorts of problems. Dimitri's just talked about lots of them. They can end up in reporting tools. We can report incorrect numbers, either too high, too low. We can also, some reporting tools will just make duplicates disappear if the entire row is duplicated for us, but others don't, and then we can experience problems. So we can get inconsistency and unpredictability. We can also, when we got to merge data together, and at least one of those 2 sets of data we're going to merge has duplicates in, we can have an explosion of our data after merging them. And we talked quite a lot about that in our last webinar on different ways and different types of merging data. And also kind of that unpredictability element. If we've got this table of product IDs and we want to look up product 2, are we going to get back keyboard or are we going to get back monitor? And maybe we'll get keyboard this time and maybe we'll get monitor next time. And that could be a problem because we can't rely on those results. So let's take a look at a set of data that's got some real problems in there for duplicates, and we can look at how we can detect them initially by exploring and profiling this data in EasyMorph and some of the tools available to fix it. So this data is a simple Excel spreadsheet or it is Excel spreadsheet, and it contains an employer directory. So we would expect that every one of our employees are in here and that they are only in here once, and it contains all of that contact information for those employees. And we want to use this data in some way, but before we do, we want to explore it and make sure that it's not got duplicates in it, because as I said, our expectation is that we would not have duplicate values. So I'll open up EasyMorph Desktop and let's do the simplest thing possible to load data in EasyMorph, which is to simply drag that file in and let go of it, and we've loaded our data. So there's our table of data, our Excel table, and we can start to look at this set of data and understand it using various tools available to us in EasyMorph. And the first one I want to look at is the table metadata. So if we right click on any action, we can select the option View Table Metadata. Sometimes this gets called the Table Profiler window as well. And this window shows us all of the fields available in our data set that we've got selected. And we can see all of those fields listed. And it tells us various information about them. And we will keep coming back to this over the examples we look at to look at some of the other information. But the first 3 columns show us some quite important information that help us to identify if we've got duplicate values. Now, at the very top of the window, we can see that there are 1,052 employee records in here. And that all-important employee ID column we mentioned has actually got only 110 distinct, unique employee IDs. So because there is that difference, we've got more rows than there are unique employee IDs. We've got to have some duplicate values in here. And in fact, our column that's next to it called uniqueness gives us an indication of how big this problem will be. So we can see that we've got only 96% of those distinct values are entirely unique. So just under 4% are duplicates within our table, and this is a problem. We might have duplicate first names, that's normal. We might have duplicate last names, etc. But employee ID is the one we care about, and so that fact that that uniqueness score is not 100%, that's a problem for us. So let's look at how we can start to find these and identify these within EasyMorph. So the first thing we can try to do is to add the deduplicate action. And so I will add a new action. If EasyMorph wants to listen, let's try that again. Let me close it and reopen it and see if it will behave for me then. I will bring this back and I'll reload that data and we'll try again. There we go. So I'll add a new action. There we go. Now we're working. So we have a action called deduplicate, which is incredibly handy in this situation. We can add that to the column and to the table. And as we can see, there are two kind of modes, if you like, that you can use the deduplicate action in. The first is all columns. So that will sort and get rid of all that scenario where the entire row is duplicated. And hopefully then that will have got rid of all of our duplicate values and solved our problem. So let's just double check that table metadata again to profile our data again. And unfortunately, we can see that our uniqueness score has got better. It's now nearly 98%, but there are still duplicates. So it didn't quite do what we needed. There are still duplicate values. So it's clear that some of those fields are not identical between their duplicates, and we need to explore it a bit more and look at solving the problem in a bit more detailed way. The other mode then is to pick the columns that we expect to be unique and to deduplicate based on those columns. And so I will pick that all-important employee ID. And in that scenario, then hopefully we can look at that table again, and we can know that if we look at our metadata, yeah, we've fixed it. We've got 100% uniqueness now. And okay, we may have solved our problem. However, we know that there are some potential duplicates in there where the data is not the same. And so we should probably look at those and find out what they are before we go just automatically deduplicating and getting rid of them, and when in fact we might be getting rid of the wrong information. So there is one other action around duplicates that's really handy, and that is if we look at just duplicate, we have a keep duplicates action we can bring in, and that will again has the same two modes, but it allows us to look at the data just to keep those duplicate rows, so we can see the 83 rows that are duplicated, and we can explore it and see why it might be different and sometimes and not in others. So as we look down it, we can see that the majority, the first couple look pretty much identical. But as we get a little bit further, we can see that the third person, actually same employee ID, same name, but they've got two different offices. They've got different information about them as well. And if we slide a little over to the right, we can see that one of our columns is the start date. And so what I think is happening here is we've got an employee who worked for us, they've left and they've come back. And unfortunately, we've got both records for them. And so what we really need is just to keep the most recent one of those records. So it's important to know that if we use the deduplicate action, it always keeps the first one that it comes across, and it gets rid of any others that it comes across that match. And so if our most recent record for an employee isn't at the top, then it will get rid of the wrong one and it won't be accurate data we end up with. So we can tweak our table a little bit then. We'll take out that keep duplicates. We'll first of all sort our data. And we can sort our data by our start date for the employees descending to make sure the most recent start date is at the top. And now if we add that deduplicate action again to our table, select our option for only specific columns and our employee ID, then we can be confident that we've kept the most recent record for any employee ID, and we should now have a correct number of employees in our employee catalogue, and we've solved our first data quality problem. So just very quickly to recap then, some of those things available to us. There's the profiler. We looked at the table profiler. There's also column profiler, which we'll look at in a minute. We've got that keep duplicates action, so we can actually see those duplicates and understand them. And then we've got various actions and available to us. We've got that deduplicates row action, or if we need to make sure we're deduplicating and getting rid of the correct values, we can use the sort actions to put them into the right order before we deduplicate. And of course, we could, if we can't just automatically get rid of those duplicates, we don't know which one's the right one to keep, we could keep those duplicate values and filter them off and send them our way in an email to somebody to fix for us, to solve the problem manually instead. So let's look at the next big data quality sort of problem that comes up really commonly, and that is the wrong data types. Now, this can be any set of data really stored in the wrong way, but the most common is where we've got numerical values actually coming in or being stored as text. And the most common of these of all is dates. So dates are normally stored as numbers because they become really useful to us when they're numbers. We can take one date from another and work out how many days there were between them, or we can test if one date is after another, etc. And if they're stored as text, that becomes much more problematic. And again, just like Dimitri was describing earlier, these kind of problems can cause incorrect numbers that can have real impacts in our kind of real data, and it can also cause problems in just sort of formatting them. If it's already formatted in a text string, converting it into a different format for a different country standard, that can be really difficult when it's not stored as a nice number for us. So let's take ourselves back to our data for a minute. We'll look at the data for our second example, the wrong data types. And this time we've got some manufacturing data. So I'll very quickly open it in Excel again. We can see that this time there's a load of information about machines, manufacturing products, who's operating that machine, when the products were made, etc., and how much we're producing. And we want to filter this and produce our daily report on this data. But first, has it got any data problems specifically around bad data types? So let's open back up EasyMorph. I will create a new project. So I've got a nice clean blank canvas. And as I did before, let's just drag our, this time, CSV file in, and we can take a look at this data and what we might have to do to solve problems in it. Now, as we can see, this data is a mixture of sort of text values, but also values which are numeric. And EasyMorph shows us these sort of very, very high level sort of indicator as to the type of data in the same way Excel does. So in Excel, we're all used to the fact that Excel shows us text values, default aligned to the left. You can, of course, override it. And the default for numbers is it's aligned to the right. And EasyMorph does exactly the same thing to us. So our status column, we can see, is all aligned left because it's text, but our columns after that are all numeric, and so they're aligned to the right. So just looking at the data, we can very quickly see in EasyMorph if there's any values which look like they might not be coming in as either a numeric value of some form or a text value. Now, as I said, the most common way this happens is with dates, especially when you load them from CSV files, as we've done here, because they tend to be written to the CSV file as something you and I could read, and not just a numeric that indicates the data. And so our timestamp field, as we can see here, is all aligned to the left. And so that tells us at a quick glance that we've got a problem and that it is sort of bringing those in as text and not numeric values. We can confirm it. Last time we looked at the table profiler. This time I will look at the column profiler. So if I click on the column header of our column, I can do filter/profile, and we get a window with lots of options in this window. We'll come back and look at a few more of them later. But the second column in here can be our profile tab. And this can give us an indication of the different types of values we've got in this. And as we can see, all of this column is showing as text instead of numbers being stored, and that's our problem. And we can click all the columns in our data, we can get to see different values. So you can very quickly leave this profiler open, click across the table into different columns and explore. And sometimes you can sort of, here we've all got them all as text instead of numbers, but you could have a mixture. You could have some as numbers and some being stored as text. So this is helpful to be able to see that. And if you did have only some of them, you can click the filter button and that will add a filter. So again, a bit like we added the filter action in our last example, we can see just those records that are problematic. Now, thankfully, EasyMorph again has an action that helps us solve this really quickly and easily. If I add a new action, this time I will look for our convert data type action. I'll bring this in. We can pick the column or columns that we want to fix. We want to pick our timestamp. We can tell it how we want to convert it. So we could say in this instance, we want to convert text to dates, and that includes timestamps that include a date and a time. But we could also do date text to numbers or everything to text just to clean it all up, etc. So we got multiple options. We want the text to date. We now need to tell it how to interpret that text to turn it into a meaningful date. And that means sometimes writing a format. Thankfully, we don't have to write them ourselves. We've got a nice button that we can click, detect, and EasyMorph will look at the data in that column and try and work out the format for us. And we can just click the button and we get the format for us, and then we can try it, and hopefully most of the time it gets it right, and you can just apply and we can fix our data. Now we can see that all the data align to the right, but now it's showing us a number, and that's perfectly fine. If we're going to output this to a database or to a different system, it's probably perfectly fine for us to output it as it is, but you and I can't read those numbers and know what the data is very easily. So just for our benefit within EasyMorph, when we're working with the data, if we pick the column, we can change at the top here. We have an option to change the format. This doesn't format the underlying number. It won't change it back to text. It just turns it into something that you and I can read again whilst we're looking at it in EasyMorph. And we can pick our timestamp format and we're back to seeing what looks like the timestamps we saw before, but now they're aligned to the right. So we've fixed our data problem and we can use this data with confidence that next time it's all going to be right. So again, just to recap as we did before, it's lots of capabilities available. Again, that alignment in the cells. We also have the various profilers available, the cell profiler as well as the column profiler, and also to look at that metadata bar that we saw at the top where we changed the format. It also gives us an indication as well of values and what their formats are. And that really useful action, convert data type, which helps us solve that really quickly. So on to our third one, and this one's one we'll all have experienced, and that's blank values or empty values, also known as nulls. And these are really common and they can cause us all sorts of very similar problems. Again, incorrect data in reports, missing data from reports as well. If we're trying to do a report for everything in the last month and a date's blank, we're not going to get that record and we're going to be missing some sales, for example. Or again, if we're going to do a merge or a lookup into this example table, then we might look up number 3, but we're going to get no value back, and that's going to cause us a problem down the line. So let's look at our next set of data and we can see what that looks like. Now, this time I've got some data, which is a whole load of insurance claims against insurance policies, what types of claims they are, and how much was claimed, etc. of this information. And we're going to load this in to EasyMorph. So I will again go back to EasyMorph desktop. We'll create a new project again. We can, as we did before, we can bring in our insurance claims. And we can start to see if we might have any problems. Again, as we did previously, I'll right click on my action and look at the view table metadata. And as we had with the uniqueness, we also have a column next in this that tells us if we've got any empty values. And we can see that thankfully, most of our columns don't have any empty values, apart from our claim amount column, 42 of which have blank values. And that's a problem for us. They shouldn't be blank. That's going to cause us problems in our reports. So let's take a look and we can see how we can actually confirm that. The first thing would be to add one of our filter actions, filter by type. And the filter by type action has the ability to both keep or remove them. So if I just wanted to take out those blank ones, I could change it to remove those, or I can choose to keep them if I need to see them, or I want to pick them to be able to send to somebody to look at. And I have the option in the type to pick empty values as well. Now, again, I could do the entire column, or I could pick just the columns I care about. In this example, it doesn't matter. We've only got one column. So I'll just do my entire table, and we can see that, yes, indeed, we do have some of our insurance claims are blank, and we could need to do something about those. Now, what we might need to do about those would vary greatly. Maybe we could just replace them with a default value. Maybe they've not yet been finalized, the value. So for now, we can just populate them with 0 so that it doesn't cause problems and it is a real number. So we could indeed add a replace action. We could pick our claim amount, and we could indeed pick those empty ones, make them 0, apply that change. We'll take out our filter. So we're doing so our whole table. And now we know at least there is a number value in all of those. That may not be right. It may not be possible. You could, again, filter on them, and you could send them in an email to somebody to be able to solve the problem. We could even derive 2 tables, and we can, from this table, we could filter then for, if I remove that, if I add my filter again by type as empty, I can send those, then automate adding email actions in EasyMorph to automate sending an email to somebody to alert that there are empty records and to attach those problem records. And for all the ones that aren't a problem, well, I can simply use that same action by cloning it. But if I move it to my other table, I could change that to remove those blank ones, and I could send the data that is fine without blanks into my report or BI tool or whatever I want to do with it, so that most of the data still keeps passing down the chain and working, but we don't able to sort of keep propagating those problems downstream. So again, as we did, just recap, we've only looked at some of the things. There are other tools available to able to help you. Again, there's lots of scenarios where blanks can happen. All of those profilers we've looked at already, the column profiler, the table profiler, the cell profilers can all help to find those empty values. There's that filter by type action, and if you need to do something a little bit more complex, then there is a isEmpty function which you can use in EasyMorph expressions as well to create some a little bit more complex check. And various tools, we looked at some of them, such as the replace. There's also a table-wide replace feature, but also we have various tools that are useful, such as fill down and fill right. So sometimes we bring in data from, say, Excel, where there's merged columns or merged cells, and we only get the value in the first cell of those merged kind of rows, and things like fill down can help us to automatically populate that value down to all the rows below that were blank because they were merged columns. So lots of tools available to solve these sort of empty values in EasyMorph. And lastly, another really common, or lastly from me, there's a really common sort of problem that can exist, and that is within lots of textual data, especially when human beings are typing that in, we can get all sorts of problems and special characters that can cause issues. Now, these can often be extra spaces that are in there. So we may have extra spaces at the beginning or at the end that are not necessary, or we could have 3 or 4 spaces in a row in the middle of the piece of text. We can also have special characters that are either unprintable characters, so we can never see that they're actually there, or we can have characters such as line feeds or special characters that can cause lots of problems. So again, we can just have extra characters that are unnecessary and they can make our data bigger. We could also have characters that might break downstream reports and things, or even systems. So if somebody typed some HTML, for example, into this text field, and we've sent that to a system that just displays that in a web page, well, that HTML could break the rest of the web page, and it can even pose security risks. So these kind of special characters, problematic characters, can be a real concern in data when we exist, as well as just making it messy. So let's look at my last example. We'll again, this time, kind of go back to our examples. This time I'll start by just opening a workflow that I've created just to get us started. You'll see why in a second. So this time our set of data is a load of comments that were on articles on a web page. So these are things that people have free typed into our website, or not our real website, a website, and therefore they could contain all sorts of problems. Some of those problems are easy to see. We've got some spaces at the beginning of some of them that make it look indented, but others can be really difficult to see. Spaces at the end, well, they're not very visible to us, or special characters sometimes just don't get printed to the screen, so we never see them, but they are there and could cause problems. So the first way we could start to look at some of these problems, if it is only specific characters or things that we really care about, is to create expressions, to create a flag column, if you like, to indicate that there is an issue there. So I've, just to get us started and demonstrate quickly, I've created an expression for us that looks for just specific problems that I'm interested in this case. So I'm interested in if there is extra spaces at the beginning or the end of our text, using the left function for the first character, the right function for the last character, to see if it's space. And if it is, I'm going to output an error to tell me there's a space there. And then I'm doing a very similar thing for multiple spaces, for tab characters, and also for a couple of specific characters, which are line feed characters, character 10, character 13, not to get too technical. So this example would be very specific in this case, and I've got some problems, and indeed I can see already that some of my data has indeed got one of those flags to say there is one of these problems in that data. We need to do something about it. So we could, of course, filter on those. We could send them off to somebody to try and get them to manually go through them, but that would be very time consuming and boring. And thankfully, EasyMorph does have an action that's very quick to implement and to solve this problem. So we have the sanitize action. Sanitize action has lots of options to fix just about every one of those problems we've talked about. So we can remove tabs, we could replace line breaks with spaces, we can get rid of all these special characters we talked about. We could pick just the specific ones we care about, and we can add that if we place that before our action that detects it. Well, now we can see that we fixed all those problems and they're all gone away for us. And thankfully, we've solved that problem. So lots of tools again, just the visibility of the data in that data grid in EasyMorph versus other tools is very useful, as well as those other functions and things we looked at as well. There's also in the column profile a suggestions tab that often helps by showing us some of those suggestions, as we can see in the example here, and then that sanitized action, as well as maybe filtering those off and sending them to somebody. So with that, I'll hand back over to Dimitri, who will take us through the final few examples that we're going to look at today.
Thank you, Matt. I'm sharing my screen. All right, so the next example we will talk about is finding outliers and anomalies. Again, quite a common problem in data where we expect values to be in a certain range, and then for some reason we get some values either extremely big or extremely small. This can happen for many reasons. For instance, especially if you deal in an international environment where you collect data coming from different countries. Well, there can be different number formatting rules where, let's say, in one country's well, the decimal separator is comma, in other countries it's a dot, but you may have a workflow that doesn't distinguish between the two. So, and as a result, you can get numbers that are much bigger than they should be. So that's just one example. Also, it could be, again, human errors and wrong calculations. So, well, there are multiple reasons why this can happen. So how do we deal with this in EasyMore? Here is an example where we load where we load the data coming from a, it's probably grocery store with different types of payments. So we have I'll make it a bit bigger on my screen so that you can see it. So we here we have a timestamp, a register number, a cashier name, sales amount, and the payment method. So in this case, we will look at the sales amount column because if we look closer at it, first of all, we do it by double-clicking the sales amount column, and now we open the column profiler so we can see all the values in it. Conveniently, it sorts all the values in ascending order, so we can immediately see all the smallest values. Well, nothing wrong with that. At least we don't see any negative values here, which would be strange. But if you scroll all the way down, we see that, well, some numbers are strangely big. They are too big, and clearly something is off here. Another way how we can profile this column and find outliers is using the profile tab. Oh, sorry, the histogram tab. And the histogram, we see a distribution of column values as a histogram bars, and we can see that while most of the values lie well within a small range, there are small bars, barely noticeable here, that clearly indicate well, some kind of outlier. So what we can do here, we can drag these rulers, and we can specify a range that we want to look at, like that, and press filter range. And now EasyMorph automatically creates a filter, and we can see and look exactly at those suspicious values. Then we can decide what to do with it. One option, again, we can, as Matt mentioned, we can send emails with these bad values to someone for revision. We can raise an issue in an EasyMorph board, or we can send a message in Teams or Slack to inform that, well, there is something wrong with it. Another problem that hides in this data set is in the timestamp column. Again, if you double-click the timestamp column, and we can look at the formatted values. So initially, they all look good, but if you again scroll all the way down, we start seeing strange things. We start seeing well-formatted values that clearly are in the future. So something is wrong with that. And we can also use the histogram tab with dates as well. So here we will again adjust the rulers and press filter range. And now we get we see all those suspicious timestamps that are clearly in the future. A small tip with the histogram representation. The number of bins it shows is dynamic. So if you expand it, it will increase the number of bins. So if you want to see more histogram bars, simply expand this dialog, and now you will see more histogram bars that will give you a more granular picture. Let's look at the next example. This time, so let's go back to our slide deck. Yeah, so how to identify with the profiler tab in different ways. And also we could use the keep min max action, which is useful for such scenarios as well. The next example we will look at, it's also a common problem in data preparation, is the wrong relationships. Sometimes you can look at data and everything looks good. No missed values, no outliers, no broken, like everything looks right from a technical perspective. But from a business perspective, this number is wrong because it has wrong relationships. What do we mean by that? So let's look at our next example. So here we see two database tables. One database table contains shipments, and another database table contains orders. Well, if you look at the numbers, well, let's say shipment IDs all look right, five characters as we expected. If you look at orders, again, they all look right, nothing suspicious at first glance. Then, but if you start digging deeper, we will start seeing that something is off, and we can detect this problem when we do a join, and we start seeing, okay, well, there are some empty rows. Well, something clearly is not right. A very useful tool is the merge profiler. So in the merge action, we click the profile button. Now we see the merge profiler. It's a very good tool when you do joins and merge data especially from different sources. That shows you a map of your join. So what can you see here? Well, first of all, immediately it shows you that there are some duplicate keys. And when you did your join, well, you expected shipments and orders to be unique, meaning or having so-called one-to-one relationship, which means that one order must have only one shipment and the other way around. But the merge profiler shows us that there are duplicates. We can click those areas to see even what's wrong with that, if there are any problems, and we can explore them in more detail. Well, for instance, here we can clearly see that order ID is duplicated, like 20,000. There are duplicates here. Also, we see that some of the records didn't match. We had the shipments table on the right, the orders table on the left, and we see that some orders didn't get shipments. We can see it. We can also click numbers right in this table here as well. And the other way around, we can see that we have shipments that are orphans, so shipments that don't have orders, and these shipments weren't merged into the order table because there are no relevant orders for them. So with the help of a merge profiler, we identified a number of problems. So now let's try to fix those problems. First of all, if you look at the shipments table, we can switch to the so-called analysis view here. And if you're not familiar with analysis view, I highly recommend using it. It's a very powerful data analysis tool. And here we can filter and analyze data on the fly without creating additional actions. So I created two filters for shipments and for orders. For shipment ID, EasyMorph immediately tells me that all values in this column are unique. But when we look at the order ID column, we don't see this all unique flag, which means that, well, there are duplicates. How to find them? That's easy. We just click the count column in this filter, and it will sort all the values by count, and it will bring values with the count more than one to the top, so we can immediately see all the orders that are duplicated in this table. We can select them if you want to look closer at them. So, well, we can see that well, indeed we have some duplicates values here. So let's fix that. What we can do, we can add the deduplicate action, deduplicate rows here, and we deduplicate not the whole data set, but using only one column order ID. Now let's look at our join. Again, we go back to the merge profile and look at that. We don't see those duplicate records here. So now we fixed this problem. But then we have the other problem remains. We still have values in our orders table that don't have shipments. So we can create a tables where we will keep only orders that don't have shipments. Well, in this case, it's easy. We simply should filter by let's say ship date and find where it's empty. And by the way, when I click the ship date, I immediately see in this column bar, I immediately see that I have 10 empty values. I can create a filter even right from here. It's like I'll keep 10 rows with empty values. Here we go. Now I see orders that don't have shipments. We can also filter and records that have the other problem where we have shipments but no order. In this case, we create a table and we use the keep remove matching action to keep only shipments that have no order. So now again we can either send it by email or we can notify someone in Teams or maybe do something else in order to react to this problem. But good thing that we've identified it. The next scenario is incorrectly formatted data. So let's look at that one. Here we have a list of online orders that came from a partner, but and this order, it contains customer name, email, product code, product category, and a few other things. So first thing we want to check here if these emails are correct, because well, they look right at a glance, but if you look closer, then we will start seeing problems. So for instance, okay, again, nothing looks wrong here, but if you look at the profiler and select the min text length, what does it look like? And look at that. So we have clearly wrong emails. Okay, so at least we know that there are wrong emails here. So how do we get the full list of them? We can create a column which flags wrong emails, and we can use the isEmail function, that checks if it's a valid email. It won't check whether this is real email, but it will only check whether this text string looks like a valid email. So when we created that, now we can use this feature and for is valid email false, and we get a list of records that don't look like correct email, so we can react to it somehow. Another problem that hides in this table is the product code. Well, the product code is supposed to have 8 alphanumeric characters, and again, it may be true. It looks right from the first look, but let's look closer at it. For this, we will switch again into analysis view, and in analysis view, we will pick a different facet for the product code. So we added this feature earlier this year, and now in analysis view, instead of just the standard filters, we can use facets. Facets are different types of features. In this case, we will use the facet that is called text length. Text length that groups all the text values in this column by their length. So we can see that most of the values, as we expected, they have the correct length of 8 characters, but also we have some product codes with the incorrect text length, like 4, 5, 10, or even 13 characters. We can filter them and immediately see all those wrong product codes here. Well, clearly something is up with them. Now let's create a data validation rule to filter those. For that, we can use so-called regular expressions. It's a bit advanced topic. Regular expressions. Simply speaking, it's a format definition. It's a format definition made in a special using a special syntax. That syntax is quite cryptic, so remembering how to write it, it's not that easy. Luckily, in EasyMorph, we have a helper, AI-assisted helper that helps us generates formulas, including regular expressions. So I'm going to insert a column here, and we'll call it is valid. And when I open our expression editor, I switch to the Generate Expression tab. This is where the AI-powered assistant lives. Now I can simply write generate false if product code is not or does not contain 8 alphanumeric characters. Generate expression, and let's see what happens. And here we go. It generated that regular expression. You see, it's quite cryptic, but if you are more or less familiar with them, well, you will see that it's the correct expression. Now we're going to apply it. Press apply. Now we have this column is valid, and if we keep only the false values, create filter. Now we will see even more wrong values. That not only do they have wrong length, but some of them have the right length but wrong characters. Let's say like this one. If you look at it in the profiler, it has the right length, 8 characters, but it contains invalid characters. So to wrap it up, again, there are different tools, different ways how to detect incorrectly formatted data. We've shown a few of them today. That's all we wanted to demonstrate to you today. It took us a little bit longer, and thank you for staying with us a little bit longer. Now I'm going to unmute everyone, and if you have questions, please go ahead and speak. You can unmute yourself and ask questions now. Do you have any questions in the chat? Let me check it.
Not so far.
Not so far. Okay, so
I got one question, Dmitry.
Sure.
Date, I'm getting date columns that are coming in as text, but they're multiple formatted. The format's not always the same. So what do you have to do? You have to convert it twice, two actions to convert it to a date. You can't do it in one single date formula, I suppose.
If you have multiple formats, well, ideally you would want to identify these different formats and convert each of them specifically. You can do it, for instance, using regular expressions, as I just demonstrated. So you can write a rather complex request saying if the date format looks like that, like year, month, day, then mark it as type 1. Then if it's another, then mark it as type 2. So it can create pretty complex expressions. Another option I can think about. Let's use this example. So we have ship date, and just for the sake of it, we'll convert it to text. So now we have.
I can't see your screen.
Oh, sorry. I'm sharing my screen.
Your idea it'd work, I think, about putting in the convert data type action twice. One of the options is what to do if it can't convert it as you need it based upon the format. So one of those is to just carry the original value forward instead. So I think that in theory, yeah, that would work, but it's obviously a bit more complex and could cause issues where if it does manage to convert it, but the format's not quite right, it could possibly give you some problems still.
Another option would be to use the date function. And the interesting thing about the date function is that, well, it expects a text date and a format description. And this format description, well, it can look like this or like that. But the interesting thing about this function is that the format string is optional. So, which means that you can basically delegate to EasyMorph to try to find and detect the format here. So what are we going to format? Ship it date. Let's see if it works here. Yeah, well, it worked. But there is always risk that the format can be guessed incorrectly. So that's another option. So it's always better to be deterministic where you specify formats explicitly. But in this case, yes, you can use the convert data type action. Just apply it multiple times with different formats. When you convert text to date, yeah, well, use different formats. Yeah. Good. More questions? So if well, no more questions, well, thanks for joining us today. We will publish a recording of this webinar on our YouTube channel soon. So even if you missed certain things, you can rewatch the webinar and refresh in memory what we talked about. Stay tuned, subscribe to our newsletter, to our LinkedIn profile. We publish regularly announcements about future webinars and also community meetups where we discuss a broad range of questions and have guest speakers frequently. All in all, well, thanks for using EasyMorph and staying with us. If you have any questions, you are always welcome to post them on the community forum. anything you need help with, you are welcome to post the questions. Having said that, I wish you a great day, great afternoon, depending on where you are. Thanks again for joining us, and hope to see you soon again. Goodbye.
Thanks, everyone. Bye.
Yep.